This is Unit 7, Sections 7.2, Volume of Prisms and Cylinders. So in 7.1, we looked at naming these three-dimensional objects, and now specifically for 7.2, we're going to look at prisms and cylinders. So remember, we kind of grouped these two together. Prisms have two bases that are parallel and congruent, and so do cylinders. Prisms can have rectangular bases, square, they can have pentagonal, hexagons, they can have lots of different bases. A cylinder also has two congruent and parallel bases, but we already know that a cylinder has to have circle bases. So we're going to look at these two formulas for this. So on the first one, we're looking at a volume of a rectangular prism. And in this case, I think that you might have some previous knowledge about that. And so the volume formula for any rectangular prism is length times width times height. And it doesn't matter the order of the multiplication. So we're going to label, we typically have the height is between the two bases, width is something how wide something is, and length is how long it is. But the order, if I said width times length times height, it would get me the same thing. So as we're looking on number 1, it says find the volume of the following rectangular prisms, round to the nearest tenth if we need to. All right, so here I have a height. So here's a height, here's a width, here's a length. To find volume, I can do length times width times height. And so I can put this in my calculator and find that value, how much volume would be inside of that three-dimensional object. 9 times 17 times 24. Okay, this would be one way to write it. I can also use it with the parentheses just like I had here. 9 times 17 times 24. This would also get me the same answer, just like I've written it here. My calculator knows that next to the parentheses is multiplication. So when I enter this in, I get a volume of 3,672. So we've spent some time looking at areas, and we had some that got large when we had large measurements. Volume, we're talking three-dimensional. How many little tiny centimeter cubes can fit in here? Okay, these are pretty big numbers to be multiplying. There's 3,000 inside of that. So again, if I took this itty bitty cube and I fit it, if this was 1 centimeter by 1 centimeter by 1 centimeter, I could fit 3,000 in this, okay? And so the way that we write our units is we still have centimeters, but now we're looking at little cubes. So we would say centimeters cubed. And I'm going to erase that because my C looked a little connected there. So centimeters cubed. So this will be our new unit based on how many cubes fit inside that object. We'll fill the volume. All right, on number 2, I see a height, a width, and a length here. So I can find volume. Again, it doesn't matter if I put these in a certain order. I typically want height to be between the two bases, so I'm going to be consistent that way. But the length and width, it doesn't matter if I had switched those. So I'm going to do 10 times 14 times 4.5. Okay, so I am introducing a decimal, and I need to remember to round to the nearest tenth if I need to. All right, so in my calculator, I'm going to go 10 times 14 times the 4.5. So how many cubic inches can fit in there? And I get 630. I didn't need to round. So I have 630, and now my label is inches cubed. So just like this one was a centimeter by a centimeter by a centimeter, now we would have an inch by an inch by an inch that would fit into this box. On our third rectangle, okay, now I'm seeing base here to base here. So here's my height and width and length. So my volume, I'm going to go length times width times height. Okay, the nice thing is when we have a rectangular prism, we can do this pretty quick. It doesn't, it might be even something that you've done in your previous math classes. but we want to make sure we're recognizing that it's a rectangular prism because we're going to talk about other ones as well. So again, I'm putting this in my calculator, 12 times 8 times 39, and I get 3,744. And now I have a label of feet cubed. This would be huge, 39 feet tall. This is almost like a building that's being constructed here or something. I mean, 39 feet tall by 15 feet. There's got to be something that's very large there. All right, so here's how we find the volume of a rectangular prism. The next one, what about the volume of any other prism? So a triangular, we did rectangular, triangular, hexagonal, pentagonal. How do we find the area of those? A trapezoid. So what we're going to do is we're going to take the area of the base, and so now we have a capital B, which is why I was picky when we were writing those area formulas in Unit 6. It does matter. The notation in math is very consistent. And so when we have a capital letter, it's typically an area or an increased notation here. So now our base might change. Okay, so that's why we're just going to use, this is the area of that base. Then we multiply times the height between the bases. And so whatever this is, we're going to have that many of them going all the way up to the other base here. So if I take this base and stack it 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 and stack it, height number of times, it would give me the volume of the entire figure. When we look at this formula, do you see that we have a rectangular area inside of this? So this is actually area of the base times height as well. So if you want to know one formula, this is the formula for really any prism. We can just do the rectangular ones pretty fast. All right, so the first thing we have to do is be able to identify what our base is, and then we need to find the area and then multiply times the height. All right, so shading in here. Find the volume of each prism below and round to the nearest tenth if necessary. All right, so we have a lot of measurements on here. So we need to figure out what's our height, what kind of base do we have. So I'm going to put base here and height here. So I don't see an apex. This is still a prism. And then I see this triangle here. Okay, here's a triangle, and there's the other triangle on top. So this is going to be a triangular base. And so this is how I kind of use my notation here. So to find the area of our triangle, we have a formula sheet up front to remind us of those area formulas, but we also practice this in Unit 6. So the triangle is going to be base times height divided by 2. So if I look at this triangle, I see a base here and a height here. So that's where my perpendicular is. So base 12 times height 7.3 divided by 2. So I'm going to find the area of the base. Let me grab my calculator and let's find what that calculation is. 12 times 7.3, base times height, divided by 2. And so again, I can write that as divide by 2, or if I want it to match exactly what was written there, I can say divided by 2. Either way will get me the same answer that says the area of that base is 43.8. Okay, so now what about the height? I found the area here. The height is between the bases. Okay, so if here's one base, and here's my other base, what is this length connecting to it? How long is this? How long is this? How long is this? And as soon as I see that, I saw the height of this is 5. So this was actually not measuring up and down height, but the distance between the bases is always the height between the bases. So to find volume, our formula says take the area of the base and multiply it times the height. So we'll do 43.8 times 5. So again, I'm going to grab my calculator and let it do that for me. 43.8 times 5. Rounded to the nearest tenth. Well, I don't need to round. I get exactly 219. Looking at my units, I will have feet cubed as my final answer. All right, on number 2, again, we have a prism. So we need to find the area of the base and the height. All right, so what kind of prism do we have here? I see my 2 triangles connected by my rectangle. So I have a base here across from the other base on the other side here, those 2 triangles. Area of the base, if I'm doing a triangle, is going to be base times height divided by 2. So here's the base of my triangle times here's the height of my triangle divided by 2. Let my calculator do that for me. So 11 times 5.4 divided by 2, 29.7. Okay, so 29.7 for the area of my base. And then the height, distance between bases. So here's part of the base. This is my connection. I don't know that one. I don't know that one. Ah, there it is. There's my height is 16. I wanted to do 2 in a row where the height wasn't up and down. And in fact, I think I do 3 in a row. The height is not up and down. If you were laying down and I said, how tall are you? You wouldn't then measure how far off your your belly is off the ground. You wouldn't say, well, I don't know how tall I am. It would be the same height whether you're laying down or standing up. Height is the distance between your head and toes. For any prism, it's the distance between the 2 bases. So to finish this off, we need volume, which is area of the base. So I'm going to use that 29.7 times the height, 16. And on my calculator, I'll go 29.7 times 16. And what do I get? 475.2. So again, this was already rounded to the nearest tenth for me. So I can write that down, 475.2. And this is going to be, not feet. Ours is measured in millimeters now. So millimeters cubed. So there would be 475.2 millimeters that could fit inside of that object. All right, on our third one here. Okay, so prism. All right, so I need my 2 bases, and I see these 2 trapezoids. So here's one of the bases that I'm seeing here across from the other trapezoid on this side. Okay, so my base is now a trapezoid base, and then I need a height, distance between bases. So the area formula, and again, this is from last unit, but if you don't remember the formulas, you don't have to have them memorized, but you need to know how to use them. This would be base plus base divided by 2 times the height. Careful on some of these formulas where we are using a height, but it's not the height of the object, it's the height of the base. So in this case, I have a base, so I'm going to say 14, plus I have another base. Okay, so that's going to be the same length as my 36, divided by 2, and then the height of my trapezoid is 17.9. Okay, so this is going to give me my area of my base. And so as I look at this, I need to put that in my calculator. So I'm going to have 14 plus 36, and then divide that by 2, and times that by 17.9. Okay, so I get 447.5 for my area of my base. If I wanted it to look exactly as how I had written it there, I could have written that out all at once too. 14 plus 36 over 2, parentheses, times our 17.9. And I would have gotten the same number. I just did one step by step. This one does it all at once. All right, so now we have our volume is going to be setting up 447.5 times the height. All right, so again, height is distance between bases. So if this is my trapezoid, we have the other trapezoid going this distance. So no matter which one I measure, each one of those will be 25, the distance between. So if I put my 25 here, that means I have my area of my base, 447.5 times 25 here. So I'll grab my calculator and put that in. We have 447.5 times 25. Double check, make sure you're getting the same thing I am. If not, we need to just practice using our calculator and I can help with that. So now I have 11,187.5 and my units are going to be meters cubed. These numbers are going to be big, and some of them, they can be big. I don't mean they have to be, but it's not wrong to get big numbers. All right, so we're going to turn our page and look at the next one. Still working with this volume formula, that's area of the base times height. And so now, okay, I still have my prism, and here's my base, because I see my two triangles that are congruent and parallel. Okay, so now I have these two, so area of the base, I'm going to do a triangle. So I have base times height divided by 2. All right, so base would be here or here, and there's my height again, but I don't know what that measurement is. And so this is where our previous units help us find those missing pieces. I need an area of the base, and I need a height in order to get volume. Well, I have no base of my triangle, even though I have a height. I can do the 28, but I need this piece for the area of my triangle. This is not the base, even though it's part of my triangle. This is not it. However, it does help me identify that's my hypotenuse. I can do 28 squared plus that unknown squared, and it has to equal the 32.5 squared. Once we have those missing pieces, then we can plug that back in. So I've just made this x. So this is where our practice from before comes back in. So now I'm going to take 32.5 squared and subtract over, because I'm trying to get x squared by itself, the 28 squared. So I get x squared is equal to 272.25, but in order to square or undo that square, I need to square root. So I'm going to take that same exact number and square root it. And so now I get x equals 16.5. This is going to be my base here with my height. All right, so once I find that, I can actually calculate it. So I have 16.5, and I'm going to set it up how it looks. 16.5 times 28, the base and height, divided by 2. And I get 231 for the area of my base. So 231 takes care of my base times the height, the distance between my bases. That's where the 31 comes in. So in my calculator to find volume, I'm going to take the area of my base, 231, times the distance between those bases, which is 31. It gives me 7,161. And my units here, I have kilometers cubed. All right, last one looking at prisms here. All right, I see another trapezoid. So I have this trapezoid on this side across from the other side here. So I have a trapezoid base, and then I need to find the height. All right, so this is going to be base plus base divided by 2 times the height of that trapezoid. All right, so I see a 25 base here. And I don't know this distance, but it should be the same as that 39.4. Oh, I need to erase that to get a height plugged in there. So what is the height of this? All right, so this would be the height. That's where our perpendicular is. And it's not given to us. So again, this is where it gets a little bit more complicated because we need to know what that is in order to do our formula for the trapezoid. Go back to seeing a right triangle. Here, we have a right triangle right here, and it's going to be the same position as back here. There's my right triangle. Here's my right triangles. It slides along that base here. And so when we look at that, this is our unknown piece. So we don't know this piece. So I'm going to put x here. So now I have x squared plus, we need to find that piece. And then I have my distance here. I do know that of 30.6 squared. So I have the 25 here, I have the 39.4 here, but I need just that little piece to find the Pythagorean theorem to make it a right triangle here. So I'm going to take 39.4 minus 25 to see what's left over for that triangle. So I get 14.4 for this piece here. All right, so now I can do my Pythagorean theorem, subtracting this over. So I'll take the 30.6 squared and subtract the 14.4 squared. That'll get me what x squared is. So x squared is 729, and then I'll square root it to get what x is, that length there. 729. Oh, and that was a perfect square, so I get x equals 27. All right, so the whole reason we did that is because we needed this value for the height of our base. So now in my calculator, I can find that. So I'm going to go parentheses, fraction. We had one base of the trapezoid plus the other base, and we average those. Divide by 2. And then we multiply by the base that we just found, 27. So the area of our base here is 869.4. And then the height of our base. So now we're going base to base. So connecting here, there's my 35. So for my final calculation, I'm going to take that 869.4, and I'm going to multiply it by sneezes by 35. And, whoo, big number, 30,000. So I get 30,429 as my final answer. So these are quite involved. We just spent an entire unit working on these pieces where we're trying to find the area, even if we have missing parts. The new part is area of the base times the height is what gives it a volume, that third dimension. The last part for today is looking at the volume of a cylinder. And so a cylinder is similar to a prism, except for that it has a circular base, which is why when we look at our formula, this is the base. Pi r squared is the formula for a circle. And so they've just rewritten it. Just like we had a rectangular base is length times width, they've said, okay, if we know the base is a cylinder, the base is a circle when we have a cylinder, then we can rewrite that capital B as pi r squared. It's always going to be pi r squared, where r is the radius and h is still the height between bases, so that distance between bases. So let's go ahead and plug and chug here. As long as we have radius and height, we can go straight to our calculator. Round to the nearest tenth. So volume here, okay, we need a radius and we need a height. The radius they give us is 18, coming out from the center to the edge of the circle. Height between the bases is 15. So I can go ahead and fill this in. Pi radius squared times 15. And so I'm ready to use my calculator. I'm going to go pi radius squared, so 18 squared times 15. Okay, so this would be the exact answer, 4,860 pi. So this would be without rounding because pi is irrational. But our directions say to round to the nearest tenth. So if I use my toggle button, the arrows right above enter, I'm going to get our approximation of 15 1,268.14. This 4 doesn't influence the 1, so I'll say 0.1. So I get 15,268.1, and now I have inches cubed as my final answer. On the second one, number 2 here, looking at a cylinder, I have circular bases. So I need to find a radius and I need to find a height. All right, so I know they're giving us this entire distance. 11 is a diameter. It's going not just to the center, but all the way through, edge to edge, through the center. So if I cut that in half, that will give me my radius of 5.5. The height, the distance between the bases, this is laying down, but I still see that height of 21. And then I'm ready to fill in my formula. Pi r squared times height. And ready to go to my calculator, it'll find this for us. Pi, don't forget pi, 5.5 squared times 21. Kind of looks like a 4, be careful. All right, so rounded to the nearest tenth, I have 1,995 points. Okay, that 9 is going to round that up to 0.7. So we have 1,995.7, and my units are meters cubed. All right, so again, I think it's quicker as soon as we know it's a cylinder, find a radius, find the height, and we can plug in. Definitely the ones that are a little bit more challenging are the triangular prism and the trapezoidal. So we need to make sure we're getting good practice on that. Make sure you're filling these in with your calculator as well. The last 2 problems today we have are applications. So on number 1, it says a cylinder, okay, so we know what that is, with a 2 centimeter diameter is drilled through the triangular prism as shown in the picture. Find the volume of the prism. All right, so it's like we drilled out this hole, and that's why it's kind of dashed in there. So this is an empty hole. It kind of reminds me of like the old pencil holders, except for 14 centimeters long would be really big. But like if you had a pencil holder, you would put the pencil through it. And so when you took it out, there was a hole in it. It's kind of what it reminds me of. All right, so we have 2 things we're going to look at. We have the prism, and so that's kind of the main thing that we're looking at. But we also have the cylinder that we need to take out. And so that's going to be kind of our new part here. So the prism, okay, we have 5, 5, 14, 7.1. But I see the base as kind of these triangles, and I'm trying to not look at not write over my circle. So the prism, I'm going to need a triangular base. And so I see 5 by 5, so I'm going to go 5 by 5 divided by 2. So that gets me my 12.5. And then my height of the prism, base to base, is 14. Okay, so now when I put this in my calculator, 12.5 area of my base times the 14, 12.5 times 14. Okay, so that's where I get 175 here. But that would be if it wasn't hollow. We've taken a cylinder out of this prism, which means we need to subtract something. So the volume of our cylinder, we need a radius and a height of our cylinder. They tell us that the cylinder has a 2 centimeter diameter or all the way across. So if this is the diameter, the radius would be half of that, so 1. The height of our cylinder goes all the way through this entire object. So we're going to have the same height here as we did for the prism here. So when I plug this into our formula, we would get pi r squared times 14. And now I want to find the overall volume. All right, so overall, I'm going to take 175 and subtract the cylinder here. So I'm going to do that on my calculator because this is pi here. All right, so I'm going to take 175. That was our area of our prism. And then subtract the pi r squared times height. There's our 14. So rounded to the nearest tenth here, 131 point, okay, that's not going to bump it up, so it'll leave it at 0. So our total volume is 131.0, and this is measured in centimeters cubed. So this is our final answer. It started out with 175, but we've taken some of that object out by creating the cylinder. All right, our last one, it says a diagram of Eric's pool is shown below. All right, so Eric's having a pool party here. He plans to fill his pool to a depth of 4 feet with a garden hose, cold water, that has an 80-foot cube per hour flow rate. Okay, so this is how much his hose can fill per hour. How many hours will it take to fill the pool? Like, should he start this right before everybody gets there? Should he start this 2 days before? How long is it going to take to fill the pool? My aunt and uncle lives down in Houston, and like everybody down there has a pool, and it takes them a long time to fill up their pool because it's huge. And then I have my brother-in-law also lives in Houston, but he has an itty-bitty pool. It does not take him very long. So it's kind of funny to think about. All right, so he plans to fill this pool to a depth of 4 feet. Okay, so it is 4.5 feet tall, but we're only going to fill it up to 4 feet here. So we're only going to go to 4 feet total. All right, so when we're trying to find the volume here, we're going to do pi radius squared, and we're only going to fill it to a depth of 4. They gave us the entire diameter. Again, edge to edge is 27, so I need to divide that in half for my radius. All right, so the volume overall on how much water he needs is we're going to take pi times 13.5 squared times 4. All right, so total, we are filling this with 2,290. 0.2, I think, double check. Yep, 0.2 will be our volume, but that's not how many hours. That's how many feet cube we need to actually fill. So how many hours is we're going to take our volume and divide by the flow rate, and that's the 80. And so if we take our volume, which we have here, and divide by 80, because that's how frequently it can, or how fast it's filling per hour, it's going to take 28.6 hours. And so he definitely doesn't want to start right before the pool party starts. He needs to start 2 days before to make sure that it's all the way filled up. All right, so as we continue in this unit, we'll have a couple applications, and if you need help with those, let me know. We had 3 main ideas that we were looking at, so today's pretty bulky. We'll spend some time reviewing and practicing, but I want you to try this and let me know if you have any questions. Have a good day.